This example comes out of section 10.1, sums and differences of function, and it's our kind of our word problem. So the setup to this problem goes like this, without writing a novel. It says the company prints booklets, costs them a fixed cost of $675, and then another $3.50 per booklet. They sell the booklets for $30 each. First question we're asked to do is to write an equation for total cost C as a function of the number of booklets produced. We'll also be asked to do the same thing for revenue, which we'll just call R versus N, and we'll do the same thing for profit, which we can call P versus N. So the cost, what it costs this company to print these booklets is C equals $675 plus $3.50 per booklet. So relatively straightforward equation, linear function. Revenue is the total amount of money you bring in, so it's just going to be $30 times the number of booklets that they actually sell. And profit is just in general, if you're not a capitalist, it just means the difference between how much money you brought in and how much things cost you. So profit, if you're wondering, in general is going to be our revenue minus our costs. And so our profit in this case is going to be 30N minus 675 plus 3.5N, the difference between those two functions. That can be simplified a little bit. 30N minus 3.5N is 26.5N, and I have minus 675. Now, the next part of this question asks us to graph these three functions on a set of axes. So when graphing these things, obviously you can reach immediately for your graphing calculator, or the fact that they're straight lines might make it a little bit more likely you do it by hand. First one has a y-intercept of 675, so we need a fairly big window on the y's, and has a slope of 3.5, and so we get a graph looking roughly like this for cost. Now you'll notice I haven't put in any numbers for n yet across the bottom. We'll decide those in a second. Now for revenue, this one is a slope of 30 goes through the origin, so it's going to be a bit of a steeper graph, and looks something like that. So there's my revenue function. Now our profit function has a y-intercept of negative 675, and a slope not quite as steep as the one we just had, but fairly similar, and looks something like that, profit. Now, when I say how many booklets to make a profit, it just means one of two things. Either where do cost and revenue meet, so this point of intersection here, or actually the same value will be where does this profit function hit zero, because as soon as you sell one more booklet than that, you've made yourself a profit. Now if you reach for your calculator and graph these functions on there in terms of y and x instead of c's and n's and r's and n's and p's and n's, you'll be able to find this thing. If you either find the intersection of cost and revenue or the x-intercept of profit, you'll find that n needs to be about 25.47. Now, n realistically doesn't make sense to be 25.5 because n represents a number of booklets. You can't really print or sell half of a booklet, and so basically means that 26 booklets would need to be sold to have profit here. If you sold 25 booklets, you'd be very close, but you'd be just below zero on the profit margin, meaning you're slightly negative. Your costs are a tiny bit higher than your revenue, but anything past that, your revenue has gone higher than your costs. The last thing I wanted to mention would be the domain of these graphs. You'll notice that I haven't bothered drawing the graph anything to the left of zero, and really it doesn't make sense. So for cost, the domains of each of these graphs here, just as an exercise, n needs to be at least greater or equal to zero. One could argue that zero booklets doesn't really make any sense either, because why would you pay the $675 if you weren't going to print any booklets? But as long as you had n is greater or equal to zero, and then n doesn't need to be real numbers, because really decimals and fractions don't make any sense here, so you could say n needs to be whole numbers, and that would be a decent domain for cost. For revenue, basically very similar thing, that n also needs to be greater or equal to 0, in that you can't really have a negative number of booklets. So for all of these, you have the same domain. So no need really for profit to rewrite it. The range would be a little bit different if you looked at them. For cost, it would have to be higher than $675. You can't pay less than that, because as soon as you start saying you want to produce booklets, that's what you pay. Revenue, on the other hand, just has to be greater than 0, or greater or equal to 0, I suppose. If you don't sell any, you don't make any. And profit could be as low as negative 675. So just looking at the graph as we have them drawn here, the range of those three graphs is what they look like they would be. For the ranges, you'd have for cost needs to be greater or equal to $675. For revenue needs to be greater or equal to 0, and for profit needs to be greater or equal to negative $675, because it is definitely possible to lose money in this scenario. So there's a word problem, definitely direct application of sum and difference of functions.